Hey everybody, so this is Mrs. Slauson and we are on page 10 in our chapter 4 packet. I thought a video key might help a little bit better since we haven't had as much time on this particular topic. So let's go ahead and get started. So there are these 4 problems, and in the 4 problems we are going to be using the elimination method, and the first step in the elimination method is to make sure that everything is lined up. So if you compare these 2 problems, again, page 10, the x's are lined up, we got our operation, the addition signs lined up, our y's, our equal signs, and then just the number. And a number that's just a plain number that's called a constant. But like on problem 13, the x's and the y's are not lined up. So I would need to do some rearranging to that particular problem. So let's start with 13. And let's go ahead. So what I'm going to do is leave the top problem alone. And I'm going to rearrange the bottom problem. Now, to make sure I don't mess anything up as far as subtraction and negative signs go, I'm going to take this subtraction and I'm just going to turn it into addition. And when I do that, I do this process called adding the opposite. So I'm just going to add. And then I'm going to take the opposite of 4x. So subtracting 4x is the same as adding negative 4x. Because the reason why I want to do this is because there's this, it's called the commutative property. And as long as everything's addition, you can switch it around. Like 2 plus 4, you can switch it around to 4 plus 2 and you won't have a different result. So now I'll put this first, the minus 3y or negative 3y second, and I'll put the 9 last. So now that everything's lined up, my goal is to, as I add each column, for one of the variables to eliminate. They cancel each other out. And hopefully you see that the x's will do that. So what I'm going to do is just make like a little plus sign, go back to elementary school. I'm going to add up my x's. They cancel each other out. When I add up the y's, think of this as negative 9y and negative 3y, I get negative 12y. When I add the constant numbers on the other side of the equal sign, again, you can use a calculator, I also get negative 12. And so real quick to solve for y, I just have to divide by negative 12. And when I do that, I get y. I get an answer of 1. So now what I need to do is go back and find x. And so when I go back and find x, I have to figure out which one I want to put this into. So I don't know if there really is a better one. I tend to go with the one that has the smallest numbers in it, or the one that's more positive numbers. So, you know, I think they're about the same as far as the amount of negative numbers, but I like this bottom one just because of the fact that they're smaller numbers overall, and that's probably going to be easier to do in my head. So I'm going to take this equation, and I'm going to take the fact that I know that y is 1, and put it into here. So it'll become negative 3 times 1 instead of y, plus that negative 4x equals 9. And then I'm just going to work on solving for x. So first let's just get this down to negative 3 by multiplying. And now to solve for x, I'm going to add 3. Those cancel out. I've got negative 4x equals 12. And then I'll divide by that negative 4, and when I'm done, I get my other solution of x equals negative 3. So again, don't forget to write your answer as an ordered pair. So I would do that and just say it's negative 3, 1. All right, let's try number 14. So here everything's lined up, so that's what I do like about this problem. However, when I do try to add these up, my x's don't eliminate and neither do the y's. So what I have to do is decide, do I want to eliminate the x's or do I want to eliminate the y's? So what I could do is build both of the x's up into some form of 2. One's a 2, one's a negative 2. Or I could take the y's and build those both up so there's some form of 7. One would be 7y, the other would be negative 7y. So again, it really doesn't matter, but I like to work with the smaller numbers. So I'm going to change my x's into 2's. So the bottom one already is 2x, so I don't have to touch that one. So I'll just rewrite it here. But what I can do with the top one is, so that the x's eliminate, is turn this into negative 2x. And I'll do that by taking everything, every term, and multiplying it by negative 2. So multiply this by negative 2, this by negative 2, and this by negative 2. Just think of it as distributing to everything. So I'll get negative 2x. When that distributes in, I'll get negative 2y. and then I'll get negative 4. So now I'm going to add these up, and now I like this because the x's cancel each other out. When I add up the y's, I get 5y, bring down that equal sign, and when I add up the constant numbers, I get a 5. So at this point, I can just divide by 5 and get my answer of 1. So now that I have y, I'll have to go back and figure out x. So again, it really doesn't matter which one I substitute back into. I always go back to the original equations, and so when I pick, again, just because I like smaller numbers, I'm going to choose the top version before I changed it. So I'm going to take this x plus y equals 2, this original equation over here, and the fact that y equals 1, I'm going to put that 1 into the y, and now I'm going to solve for x. So just subtracting 1, and when I do that, I get my x value of 1. So here, my x and y value turn out to be the same value. I get 1 comma 1 because I'm writing it as an ordered pair. All right, let's take a look at 15. So on 15, when I look, so I like the fact that everything's lined up, but what I want to add, my x's nor my y's cancel out. So again, I have a choice. So I could make the x's both some form of 2, or when I try to think of a number that I could make 7 and 2 into, I've got to build the numbers up. I'm going to be multiplying them. I could turn those both into some form of 14 and then eliminate. So when I look at what's the least amount of work, if I decide to change the y's, I have to change this into 14y, and I have to change maybe this one into negative 14y. So I have to change both equations. What I'd rather do is change the x's, because if I can make these both 2, well, one of them already is the 2x, so I don't have to change it, so it's less work. So the top one I'm not going to rearrange, I'm just going to rewrite it down here. And the bottom one, I'm going to now take it times, if this is a 2x, I need to make the bottom one a negative 2x. And since the negative's already there, I just have to multiply everything by 2 and get there. So don't think that that's a pattern that everything multiplies by 2 just because that happened on 14. So I'm going to multiply everything in here by 2, so that becomes negative 2x. This becomes a negative 4y, or subtracting 4y, and the 2 times the 2, that's a 4. So now I'm ready to add them up. Again, my x's will cancel out. I'm going to add these up. I get 3y. Let's bring down the equal sign. I'll add those up. I get 3. And then to solve, I just quickly divide by 3, and I get y to be 1. And now that I have y, let's go back and put it in for x. So, and solve for x, sorry. So going back to the original ones, this is just bigger numbers than this one. It's kind of up to you. What I don't like about the bottom one is this negative x. Maybe you could make it negative 1x if that's more comfortable. That's what I would probably do. So with that idea, I'm going to take the bottom one unchanged, this negative 1x minus 2y equals 2, and I'll take the fact that y is 1 and just put it into there. So I'll have negative 1x minus 2, and then in for y will go the 1. And now I'm going to solve. So first, let's just clean this up a little bit. Take 2 times 1, which is 2. And now to solve for x, I'm going to add the 2 over, and that gives me 4. And then I'll get negative 1x, whoops. And then to solve for x, I'll divide by negative 1, and I get my answer of negative 4, because when I do divide those, I get negative 4. So again, writing my answer as an ordered pair, it's negative 4, 1. All right, last problem. So again, what I like about 16 is that everything's lined up. So let's decide what we want to eliminate. So 6 and 4, I'd have to build both of those up. If I'm looking for the smallest number, I could turn both of those into a 12, but then I have to change both of them. Or when I look at the y's, I could turn both of those into 2, which would be less work. So that's what I'm going to do. I'm going to turn the y's into 2. So since this one is already the minus 2y, I'll leave that one alone and just rewrite it here. And that means to get this, I'll have to make it a positive 2y. And the reason why is because that's like a negative 2y. So if I look at what it is already, it is a negative y. So first I'll have to just multiply by 2 to turn it into the 2y. But I'll have to multiply it by negative 2y, because when this negative multiplies that, it'll turn it into a positive 2y. So I'm going to distribute everything. So negative 2 with the 6x is negative 12x. Negative 2 with the subtracting y becomes adding 2y. and negative 2 with 3 becomes negative 6. So again, I realize there is this pattern that we always multiplied by 2. That is just very coincidental for these problems. You might multiply by 3. Okay, so let's add everything up. I always drawing my wall in here. So when I add the x's, 4 and negative 12 becomes negative 8. The y's will cancel each other out. When I add up those numbers, I get negative 8. And now quickly divide by negative 8 to solve for x. And when you do that, you get 1. And now when I go back and I decide, well, which problem do I want to put x back into? You know, I don't know really which one's better. I think I'm going to put it in the bottom one. So I'm going to take the 4x minus 2y equals negative 2, and the fact that x is 1, and I'm going to put that 1 in here, so it'll become 4 times 1 minus the 2y equaling negative 2. And now I'm going to quickly just multiply, clean this up. That becomes 4 minus 2y equals negative 2, and now I'll solve for x. So getting y alone and moving the 4 and the 2 over, I'll start by subtracting 4. So a negative 2 subtracting 4 is a negative 6. I'm going to move over a little bit. And then on the other side of my equal sign, I still have the negative 2y. And now to solve, I'll divide by negative 2. And now I'm done, and I've got y equals 3. So writing this as an ordered pair, I've got 1, 3. So if you take a look at the answers, again, on 16, it was 1, 3. On 15, it's negative 4, 1. 14, it's 1, 1. And 13, it's negative 3, 1. And that is the elimination method.